Hello everyone, myself Hans. Today we are going to solve the problem based on Chapit method. Here in the question, find the complete integral of the equation p square plus q square minus of 2px and minus of 2qy plus 2xy is equal to 0. Let's solve the problem. Given equation is f of x, y, z pq is equal to p square plus q square minus of 2px and minus of 2qy and of 2xy is equal to 0. Let this is equation 1. We have to use the Chapit method in the following problem, and Chapit of the equation is given by Chapit auxiliary equation is given by is dp upon del f upon del x plus of p del f upon del z and dq is upon del f upon del y plus of q del f upon del z and dz upon minus of p del f upon del p and minus of q del f upon del q. For dx, that is minus of del f upon del p and dy, that is minus of del f upon del q. We must remember the following auxiliary equation. Then we have to find the del f upon del x plus of p del f upon del z using equation 1. First we have to find del f dp upon del f upon del x is del f upon del x from here, that is minus of 2px differentiating partially with respect to x, that is of minus of 2p, and again 2xy differentiating partially with respect to x plus 2y, and plus of p and again differentiating partially with respect to z, that is del f upon del z. Here is the coefficient of del f upon del z is not present, so it's become 0. Then the required dp upon minus of 2p plus 2y. Further we have to find del f upon del y from equation 1, differentiating equation 1 partially with respect to y, that is del f upon del y, that is from here the 2xy differentiating partially with respect to y, that is 2x, and again plus of q and differentiating del f upon del z with respect to z. Here is a coefficient of z is not present, so becomes 0, and del f upon del y, one second, p square plus q square plus 2px minus of q2qy. Here is some mistake. This is 2qy. Again differentiating minus of 2qy with respect to y. That is 2q. That is minus of 2q. And for dz, del f upon del p from equation 1 partially p square with respect to p, that is 2p, and minus of p is already present, that is 2p, and again minus of 2px differentiating partially with respect to p, that is minus of 2x, and this is minus of q, and again differentiating del f upon del q with respect del f upon del q, that is q square differentiating partially with respect to q, that is 2q, and minus of 2qy again differentiating partially with respect to q, that is minus of 2y is equal to dx upon we have to find minus del f upon del p, that is del f partially differentiating equation 1 with respect to p, that is p square differentiating, that is 2p, and 2px differentiating partially with respect to p minus of 2x, and minus is already present. And for dy we have to find del f upon del q, that is minus is already present, del f upon del q, that is q square differentiating partially with respect to q, that is 2q, and minus of 2qy differentiating partially with respect to q, that is minus of 2q. One second. Del f upon del q, that is minus of 2qy differentiating partially with respect to q, that is minus of 2y. Further we have to solve from each ratio. Let this is 1, this is second, and this is third, and this is fourth, and this is fifth ratio. We have to solve using taking first, second, and in the left hand side, that is dp plus dq upon minus of 2p plus 2y and plus of 2x minus of 2q is equal to taking fourth and fifth in the right hand side, that is del x upon del x plus del y upon minus of 2p, and here is plus of 2x, and from here is minus of 2q and plus of, one second, del f upon del q, that is 2y, here is 2y, that is plus of 2y. From here we have to cancel out, that is minus of 2p and minus of 2p plus 2x, minus of 2p plus 2x and plus of 2y and minus of 2q. This part is cancelled out, then the remaining is dp plus dq is equal to dx plus dy. On integrating both the sides, integrating dp, that is p, and integration of dq is q, and integration of dx is x, and integration of dy is y, and taking constant as a. Further we have to also write, that is x is taken into right hand side, that is p minus x, and plus of y is also taken into left hand side, that is q minus y is equal to a. Let this is equation 1. From equation 1, from equation 1 can be written as, that is p square plus of q square minus of 2px and minus of 2qy and plus of 2xy is equal to 0. We have to some modification in the above equation. P square plus of q square minus of 2px and minus of 2qy and plus of 2xy. We have to add and subtract plus x square and minus x square and plus of y square and minus of y square is equal to 0. We have to take, that is p square plus of x square and minus of 2px, and from here is q square, and from here that is plus of y square and minus of 2qy, and the remaining is minus of x square and minus of y square and plus of 2xy is equal to 0. Further we have to also write, that is p square plus x square minus 2px is written as p minus x ka whole square plus q square plus y square minus of 2qy is written as q minus y ka whole square, and from here that is taking minus as a common, that is x square plus of y square and minus of 2xy is equal to 0. From here we can also write that is p minus x का होल स्क्वायर प्लस ऑफ q minus y का होल स्क्वायर and minus of x square plus y square minus 2xy is taken into right hand side, that is plus of x square plus y square minus of 2xy, and we can also write x square plus y square minus 2xy is x minus y का whole square. Let this equation first, second, this is second and this is third. We use the following identity. We must remember the following identities, that is a plus b का whole square plus of a minus b का whole square is equal to 2 times of a square plus b square. Here we have to let's suppose here that is a is equal to p minus x and b is equal to q minus y. Let's suppose and expand in the following form identity, that is p minus x and plus of q minus y का whole square plus p minus x and minus of q minus y का whole square is equal to 2 times of p minus x का होल स्क्वायर प्लस q minus y का होल स्क्वायर. You can expand the following identities, that is in place of a we have to put p minus x and in place of b we have to put q minus y. Here is a is p minus x and b is q minus y, that is a plus b का होल स्क्वायर and a minus b का होल स्क्वायर is equal to 2 times of a plus b a square plus of b square. Further we have to solve, that is from here we have to put the value, once again we have to put the value of p minus x plus of q minus y in the above equation. P minus x and plus of q minus y, we have to put a, that is a square plus of p minus x and minus of q minus y का whole square is equal to 2 times of in place of p minus x का whole square and plus of q minus y का whole square. We have to put from here p minus x का whole square plus of q minus y का square. From using equation third we have to put the value, that is x minus y का whole square. Let this equation fourth. Further we have to solve adding equation second and fourth. Adding left hand side to left side and adding right hand side to right hand side. Adding equation 2 and 5, that is equation 2 of left hand side is p minus x and plus of q minus y, and equation fourth of once again we can also write equation 4, we can also write in the form of that is p minus x minus of q minus y का होल स्क्वायर इक्वल टू 2 of x minus y का होल स्क्वायर and plus of a square is taken into right hand side, that is minus of a square, and from here that is p minus x and minus of q minus y is equal to under root of 2 of x minus y का whole square minus of a square. This is equation 4, and further we have to adding equation second and fourth, that is equation second of left hand side is p minus x plus of q minus y, and equation fourth of left hand side is p minus x and minus of q minus y, and further we have to equation second of right hand side is a, and equation fourth of right hand side is under root of 1 second under root of 2 of x minus y का whole square and minus of a square. From here that is p minus x and plus of q minus y and plus of p minus x and minus of q and plus of y is equal to a plus under root of 2 of x minus y का whole square minus of a square. From here that is plus of y and minus of y is cancelled out, and plus of q and minus of q is also cancelled out, and from remaining is 2p minus of 2x is equal to a plus under root of 2 x minus y का whole square minus of a square. From here we have to find the value of p, that is 2p is equal to minus of 2x is taken into right hand side, that is a plus under root of 2 x minus y का whole square minus of a square, and minus of 2x is taken to right hand side, that is plus of 2x, and from here that is p is equal to a by 2 plus of 1 by 2 under root of 2 of x minus y का whole square minus of a square and plus of x. This is the value of p. Further we have to find the value of q. Further we have to find the value of q subtracting equation 4 minus equation 2, subtracting left hand side to left hand side and right hand side to right hand side. Equation 4 of left hand side is p minus x minus of q minus y. This is the left hand side of equation 4, and from here that is equation second of left hand side is minus of p minus x and plus of q minus y, and the equation fourth of right hand side is under root of 2 x minus y का whole square minus of a square, and from our equation second of right hand side is a, that is minus of a. From here that we can also solve further, that is p minus of x and minus of q plus of y and minus of p plus of x and minus of q and plus of y is equal to root of 2 times of x minus y का whole square minus of a square and minus of a. From here that is minus of x and plus of x is cancelled out, and minus of p and plus of p is cancelled out. Then the remaining is 2y 2y and minus of 2q is equal to under root of 2 times of x minus y का whole square minus of a square and minus of a. From here we have to find the value of minus 2q to minus of q. Then further we have to write that is minus of 2q is equal to under root of 2 times of x minus y का whole square minus of a square and minus of a is already present, and plus of 2y is taken to right hand side, that is minus of 2y. Further from here we have to q is equal to minus of q is equal to 1 by 2 times of under root 2x minus y का whole square minus of a square, and from here is minus of a by 2 and minus of y. From here we have to multiplying both the side by minus, that is q is equal to minus of 1 by 2 under root of 2 times x minus y का whole square minus of a square, and from here is plus of a by 2 and plus of y, and we can also write that is q is equal to y plus a by 2 plus y and minus of 1 by 2 under root of 2 times of x minus y का square minus a square. Further we have to use the following equation in the Chapik method, that is dz is equal to pdx plus q dy, and we have to put the value of p and q in the above equation, that is dz is equal to, in place of p we have to put the value that is a by 2 and plus of 1 by 2 under root of 2 times of x minus y का whole square and minus of a square and plus of x and whole dx. Once again we have to put the value of p here, that is whole dx, and plus of q we have to put the value of q, that is the value of q is a by 2 and plus of y and minus of 1 by 2 under root of 2 times of x minus y का whole square minus of a square dy. Further we have to solve the following, we get the required answer. Further we have to solve, that is dz is equal to On multiplying dx with everyone, that is a by 2 dx, a by 2 dx plus of 1 by 2, 1 by 2 under root of 2 times of x minus y का whole square minus of a square dx and plus x dx, and from here that is a by 2 dy and plus of y dy and minus of 1 by 2 under root of 2 times x minus y का whole square minus of a square dy. From here we can also write above equation in the form of dz is equal to, one second, a by 2 is taking common from this, that is a by 2 and dx plus dy, dx plus dy, and we can also write that from here taking 2 common from here, that is roughly we have to done here, that is under root of 2 times x minus y का whole square and minus of a square, we have to take common 2, that is under root of x minus y का whole square and minus of a by root 2 का whole square. We can also write in the form, and root 2 is taking common, that is under root of x minus y का whole square minus of a by root 2 का whole square. We can also write 1 by 2 under root 2 times of x minus y का whole square minus a square, that is 1 by 2 is already present, and under root of 2 times of x minus y का whole square minus of a square is written as root 2 of under root x minus y का whole square and minus of a by root 2 का whole square dx, and from here that is we can also write that is x dx, and we can use a by 2 earlier, that is plus of y dy, and from here we can also take common root 2 bracket x minus y का whole square minus of a square dy is written as root 2 under root of x minus y का whole square and minus of a by root 2 का whole square dy. Further we have to integrate both the side. One second, we have to take x minus y. One second. We can also write the above equation dz is equal to, we have to take first, that is x dx and plus of y dy, and then we have to write that is a by 2 dx plus dy, and from here we have to take common, that is from here that is root 2 is written as root 2 into root 2, then root 2 say 1 root 2 is cancelled out and remaining is 1 by root 2, and 1 by root 2 is taking common from here, from also here, that is root 2 is written as root 2 into root 2, and 1 root 2 is cancelled out, then the remaining is 1 upon root 2, and 1 upon root 2 is taking common, 1 upon root 2 is taking common, then the remaining is, once again, 1 upon root 2 under root of x minus y का whole square and minus of a by root 2 का whole square is taking common, and the remaining is dx minus of dy. Further, we have to also write in the form of, that is dz is equal to x dx plus of y dy and plus of a by 2 dx dy plus of 1 by root 2 under root of x minus y का होल स्क्वायर माइनस ऑफ a by root 2 का होल स्क्वायर and from here that is taking d common, that is dx minus y. From here we have to let x minus y t. We have to let on differentiating, that is dx is equal to dt. We have to put in the above result, that is putting in the place of x minus y, we have to put t, that is dz is equal to x dx plus of y dy and plus of a by 2 dx plus dy, and from here we have to plus 1 by root 2 and under root of, in place of x minus y we have to put t, that is t square, and from here we have to put a minus t square and a minus root 2 का square, and in place of dx minus y we have x minus y, we have to put t, that is dt. On integrating both the side, that is a formula used by, we can also know the following formula once again. We have to know the following formula: integration of under root of x square minus a square dx is equal to x by 2 under root of x square minus a square and minus of a square by 2 log of x plus under root of x square minus a square plus c. We can also use the mod. If I use bracket, nothing to affect in the question. We expand the following: a square minus x square and integrating both the sides, that is dz is integrating with respect to z, that is z, and x dx integration, that is x square by 2, and y dy, that is y square by 2, using the formula, that is x and dx integration, that is x n plus 1 and upon n plus 1, and from here that is a by 2 and integration of dx is x and integration of dy is y. Further 1 by root 2 and expanding the following: a square minus x square minus a square in the above formula, that is first we have to x by 2, here is the x is t, that is t by 2 and under root of x square minus a square, that is t square minus of a by root 2 का whole square and minus of a square by 2, here is a upon root 2 and a square by 2, that in place of a, here is a by root 2, that is a by 2, and already here is 2 present, that is a square by 4 log of x, in place of x we have to put t, and plus of under root t square minus under root a upon root 2 का whole square and taking constant as of b. Further we have to put in place of t we have to put x minus y, that is z is equal to, from here we have to take common by 2, that is 1 by 2 x square plus y square, and from here that is a by 2 x plus y, and plus of 1 by root 2, and we have to put in place of t, that is x minus y, that is x minus y by 2, under root of, in place of t we have to put x minus y, that is x minus y ka whole square, and we have to also square, that is a square upon 2 minus of a square upon 4 log, we have to put in place of t, that is x minus y, and plus under root of, in place of t we have to put x minus y ka whole square, and minus of a square upon 2 plus b. This is the required solution of the given problem. Thank you class, and thank you for watching.